Additional explanation for this example. So for this function, after we finding the critical point x coordinate, we substitute to the function to find the y coordinate. So this critical point, we are not sure that is maximum or minimum. So therefore, we can use our first derivative test, which is finding the gradient of tangent. You can notice that this is our critical point 0, and then this is our critical point 1 over 2, less than 0, and the interval between 0 and 1 over 2, and more than 2. So for this interval, actually, we want to see our first derivative test, which is our gradient of the tangent. So we just randomly take one numbers, and then you can notice that your first derivative means your tangent is positive going up, tangent is negative going down. So tangent here is positive going up. Actually, from here, we can identify, actually, this point, you can see go up and go down, means this point is your maximum point. X equals to 0 is your maximum point. Then, when x equals to 1 over 2, you can see your graph tangent going down and then go up. So this x equals to 1 over 2 will be your minimum point. So we are identifying this critical point using first derivative to identify it is maximum or minimum. So other than that, besides using first derivative test, we can also using second derivative test. So this is the additional method, or this is an alternative method we can identify here besides using table. So why we using this first derivative test? Because we can see from the first derivative test we can identify the increasing and decreasing interval. At the same time, we can conclude out our maximum minimum point. So other than first derivative, here is an optional method. If we want to see the increasing and decreasing, we can use our second derivative test. So when we come to second derivative test, so this is our part C. Find the relative maximum minimum for using second derivative test. So our double prime x here, we can find that it is equals to 24x minus 6. So once we differentiate this and differentiate again, so for second derivative test, to test maximum minimum, we just substitute our critical point. Let's say the first point 0, 24 times 0 minus 6, we get negative 6, less than 0. So second derivative test is discussing about concavity. When we see negative, means the concavity is downward. So from here, we also can conclude that 0, 0 for this point, 0, 0 is maximum point. So we have another critical number here, which is x equals to 1 over 2. So we substitute into our second derivative. 24, substitute 1 over 2 minus 6. So 12 minus 6 is 6. So positive value. Positive value is concave outward. So from here, we also can conclude that our second point, 1 over 2 and negative y coordinate negative 1 over 4 is minimum point. So whether to use first derivative or second derivative, we are going to depends on the question which one is more suitable. Alright, so this is an example with finding our extremum point using first derivative test and second derivative test. So when we go for inflection points, question D. So if inflection points happens at when our second derivative x equals to 0. From our first derivative, we don't find our critical point as inflection point. As you can see, our critical points, 2 points here already undergo the test, and from the test result, we can know that which one is maximum and minimum. It is confirmed that it is maximum and minimum, so it won't have this kind of situation. If the test not going to have maximum or minimum, you might get the third situation, it will be inflection point. So since our critical point that we get under we do first derivative, we already know maximum minimum, means our inflection point, when we come to inflection point, will be happen when second derivative equals to 0. So when we find out this one double prime equals to 0, we get x. So actually for this inflection point, we have to undergo our test before we conclude out this is inflection point. So for this point, 1 over 4, negative 1 over 8, it may be the inflection point. Since we haven't doing the test, we cannot conclude yet. So to justify it is a maxima, or to justify it is an inflection point, you can use first derivative test using tangent, or we can using second derivative test using concavity. So both of it we will show it to you. For the first derivative test, so we're going to see the tangent. We have to build up the interval that we need here. The interval, and then the test value that you need. And then the result, the sign of first derivative test. And lastly, the conclusion. Since our point 4 at x equals to 1 over 4, so the interval will be x less than 1 over 4. We want to see this point, before this point and after this point, so x more than 1 over 4. So the test value we can put here, so 1 over 4 is, we can test value, I put 0. So more than 1 over 4 test value, I can put 1, so that easy to calculate. Put in our first derivative 0. So first derivative, when I put 0, 0, so you can notice that our first derivative also 0. So we don't take the value that we had to do conclusion. So we take a bit more, 0.1. So you have to be careful that 0 is critical point just now. So that's why I put test value 0. It can't be, it doesn't show us any result. So less than 1 over 4, but not less than 0. So we put 0.1. So when we put 0.1, substitute into the first derivative test here, it gives us negative. So the gradient of the tangent is decreasing. So when we have more than 1 over 4, but not exceeds 1 over 2, yeah, because our critical point happens 0 and 1 over 2. So more than 1 over 4, let's say we put 0.3, also negative, decreasing. So from this conclusion also we can see, we can conclude out 1 over 4, negative 1 over 8 is a inflection point. So another method we want to discuss here will be second derivative test. So of course we get second derivative equals to 0. So to test is concavity. We find out the interval. So what's your test value? What is our second derivative result? And what's your conclusion? So x less than 1 over 4, x more than 1 over 4. Also have to be careful with our critical number. Don't exceed your critical number. When you're less than 1 over 4, don't exceed 0. So we also taking 0.1. So more than 1 over 4, don't more than 1 over 2, because after 1 over 2 is in another part of the graph already. So this one we put 0.3. So this value, we substitute into our second derivative, which is this one, 24x minus 6. So you can notice that the second derivative here is negative, here is positive. So when we do second derivative, the conclusion will be concave downward and concave outward. So you can see concave downward, concave outward. The concavity change from here, we can conclude out. So this is inflection point. Then lastly, you can draw your graph.